looking at notes 5-10, quadratic inequalities. So here are the steps to solve a quadratic inequality. First, 0 needs to be on the right. Okay, so let's look at number 1 together. So is 0 on the right? Yes. Then we're going to find the zeros or roots, x-intercept solutions, however it is asked of you, of the equation. Okay, I boxed that in red for a reason. You have to look at the equation here, not the inequality. So our first step is going to be to change this inequality sign to an equal sign. So now let's find the zeros of this equation. Okay, so the easiest way to find the zeros of this quadratic, in my opinion, is going to be factoring. Okay, we notice we have a GCF of 2x. So I'm going to factor out the 2x, and then that would leave me with, in the inside factor, x minus 7. Okay, and remember that zero product property here we can use because we've got two factors multiplied together to equal 0. So we set each factor equal to 0 and solve. So 2x equals 0 and x minus 7 equals 0. If you divide by 2 here and divide by 2 here, you would still get x equals 0. Here you add 7, here you add 7, you would get x equals 7. So what we just found from this quadratic, if you were to plug this quadratic in the y equals of your calculator, again, this quadratic crosses through the x-axis at 0 and 7. So we're going to draw a rough sketch of what that looks like. All right, so thinking about this being the x-axis, if this is the y-axis, so this is x, this is y. All right, here's 0 on the x-axis. Here's 1, 2, 3, 4, 5, 6, 7. So we've got a x-intercept at x equals 0 and an x-intercept at x equals 7. So all I've done so far is draw where the intercepts are. So I found the zeros of the equation. Now I'm going to determine how the graph opens. Well, it's either up or down, and remember that's determined upon A. All right, so how does this graph open if this is y equals 2x squared minus 14x? The A value is positive, so this graph will open up. So our graph would look something like this. And we don't know where the vertex is, and frankly, we don't care. All right, for this type of problem, we don't care. We just care where the zeros are and how the graph opens for now. Then you're going to decide which section of the graph goes with the inequality. Well, let's go back to the initial problem. Okay, if you're being asked to solve this quadratic inequality, what you're being asked is, when is the graph less than 0? Okay, and that's saying when is the graph below the x-axis, because that's when our y values are less than 0. Remember, this 0 has replaced the y. Okay, so this is really y here, but remember when we solve, we replace the y with 0. So this is saying when is the graph below the x-axis? Well, my graph is below the x-axis all here. Oops, there goes my... all here, we're below the x-axis, we're below the x-axis, we're below the x-axis, and then we get here. None of these portions of the graph are below the x-axis, agreed? They're all above the x-axis. So when I decide which section of the graph goes with the inequality, then I can write my answer in the form of an inequality. Well, what portion of the graph meets this criteria that we're less than 0, we're below the x-axis? Okay, so I'm going to write right here, below x-axis. Okay, so that answer is from 0 to 7. When x is between 0 to 7, we are below the x-axis. And not or equal to, because it doesn't want to know when we're equal to the x-axis, but only when we're below the x-axis. So again, here we're not going to put or equal to's. All right, so you're basically writing an inequality for the orange shaded region. Hopefully you can see the orange at home. Okay, so number 2, same direction, so I'll try and fit it all on the screen. So again, 0 needs to be on the right, not on the left. It's not There's no choices. It has to be on the right. So your first step is going to be to move over this -8 across the inequality. Just like moving across an equal sign, that -8 is going to turn positive. So +8 less than or equal to, now this is 0. Okay, so 0 is on the right. Then I need to find the zeros of the equation. So I'm going to change this inequality to an equal sign. And again, I'm going to solve this quadratic. Find out when this quadratic crosses the x-axis. Okay, so again, looking at this quadratic, sure, I could use quadratic formula. There's many ways you could use completing the square. Me personally, I'm going to try factoring first. Does this quadratic factor? It's faster in my opinion. So let's see. If I'm factoring, I'm looking for numbers that multiply a times c. Well, a is just 1. So 1 times 8 is 8. Multiply to 8, remember? But add to -6. And so 4 and 2, is that going to work? Yes, it is. All right, if I have -4 and -2, so x minus 4, x minus 2. So again, that zero product property, I've got two factors multiplied together to give me 0. So set each factor equal to 0 and solve. So x equals 4 and x equals 2. All right, so again, I'm going to draw my picture. Let's see, my zeros are at 2 and 4. So I'll put my y-axis here, my x-axis here. My zeros are at 2, 3, and 4. And I'm going to look at how does my graph open. So my zeros are at 2 and 4. My a value is +1. So I found the zeros. Now I'm determining how the graph opens. Okay, my a value is +1, so my graph must open up. Okay, again, I don't really care where the vertex is. I just need to know the graph opens up. So then I'm going to decide which section of the graph goes with the inequality. So again, I want to know, when is this graph less than or equal to 0? So again, below or on the x-axis. When am I below or on? Well, I'm below, and on, and all of this region. So when am I below or on? I am below the x-axis or on the x-axis from x equals 2 to x equals 4. And I do include everything in between as well as those outer boundary numbers because it is or equal to in the problem. Okay, so that's my answer for that problem. Okay, now let's look at number 3. So notice, this quadratic was in standard form once we got 0 on the right. This quadratic was in standard form once we got 0 on the right. This quadratic, 0's on the right, is in vertex form. So I've already got 0 on the right. That's the first step. Now I need to find the zeros, roots, x-intercepts, solutions of the equation. So again, I'm changing this inequality to an equals, and I'm going to think about how I'm going to solve. I can't use factoring here, not unless I'm in standard form. I'm in vertex form. Okay, so the easiest way to probably do this would be to use our square roots. So when you use square roots to solve, remember, we're going to add the 1 to both sides. So add 1, we would get equals 1. Okay, we're trying to get this quantity squared by itself. So I'm going to use my red because I'm going to multiply both sides by the reciprocal of 1/4, so 4/1. All right, so here I'm going to have, because 4/1 times 1/4 is going to turn to 1. So I'm going to have x minus 2 squared equals 4. All right, and then of course I'm going to rewrite this like I've done for you in the past, because on this step I'm going to square root both sides. And remember, what's the square root of the quantity x minus 2 squared? Oh, I hope you didn't forget. Absolute value x minus 2 equals 2. The square root of 4 is 2. How do you get rid of the absolute value? Well, you split it up into 2 problems. Or in other words, you make one problem plus and one problem minus. All right, one problem plus and one problem minus. So here you can think about this a couple of different ways. You can move over the minus 2 and put it in the back. So you've got x equals this plus or minus 2 drags down. This minus 2 becomes plus 2. So here's your 2 solutions. X equals positive 2 plus 2, that's 4. Or x equals negative 2 plus 2, that's 0. All right, so I've got my 2 solutions. They're 0 and 4, so I'm going to draw my picture. All right, here's my y-axis. Here's my x-axis. I have a solution at 0, and I have a solution at 1, 2, 3, 4. All right, how does the graph open? Okay, the graph opened up. The a value was positive. Okay, so the graph opens up again. Oops, there we go. Again, we don't really care where the vertex is because we're just looking at what's above and what's below the x-axis. So the vertex is insignificant for today's lesson. So now in this case, we want to know when is the graph, based on this symbol, above the x-axis. Not on, but above the x-axis. So, and again, I'm getting that based off the symbol. Based off the symbol there. Based off the symbol. That's how I know that. Okay, so in this case, based off the symbol, we're looking at above the x-axis. So that would be here I'm above, and here I'm above the x-axis, right? Because all this is below the x-axis. So here I'm above, and here I'm above. So now I can't use my joint inequality because I've got 2 separate pieces of the graph. Here, this whole orange was joined. This whole orange was joined. Here, the orange is here, but then I have to pick up my pencil, and it's also here. So in this case, I have to use when x is less than, that's 0, or when x is greater than 4. And again, remember, we're not or equal to because the problem wasn't given or equal to. We want to know above the x-axis, not above or on. So that would be my solution for this problem. Okay, so there we go on that one. So now let's go to number 4. Number 4, following the same directions. So we need to get that 0 on the right. So that means all of this needs to jump across the equal sign. So this will become negative x squared, positive 3x, and it's still a positive 6 is less than 0. Okay, and now I need to substitute an equals here because I've got to find the zeros of the equation. So again, we're in standard form. I'm going to try to factor. So factoring out that lead negative, I get x squared minus 3x minus 6. So I would be looking for numbers that multiply to negative 6, but add to negative 3 because my a value here is 1. 1 times negative 6 and then negative 3. So it's either going to be 1 and 6 or 2 and 3. And none of those things work. So y'all, when that happens and you can't factor, we're going to get rid of this step essentially. We're not going to factor out the lead negative. We're going back to the original problem. It didn't factor. So unfortunately, what will work every single time? I hope you're yelling at home, quadratic formula. Quadratic formula will work every single time. So unfortunately, we have to go with a quadratic formula. So remember that a is negative 1, b is 3, and c is 6. So x equals opposite of b plus or minus b squared minus 4 times a times c all over 2 times a. So we have x equals negative 3 plus or minus, all right, this is, right here, this is 9 minus, well, this is actually going to become plus because a negative times a negative will make a positive, and 4 times 1 times 6 is 24. So 9 plus 24, which is going to give us, so 9 plus 24 essentially is what we have under there. And then all over negative 2. So this is going to become x equals negative 3 plus or minus, that's 33 all over negative 2. Okay, y'all, the square root of 33 is a decimal number. You can go off to the side and break up 33, but it's just 11 and 3. Nothing's going to come out. So to get the zeros, because for this scenario, for this problem, I need to know where on the graph do we cross the x-axis. So I would plug this into the calculator, and I actually already have. Okay, I've plugged in negative 3 plus square root of 33 over negative 2 and negative 3 minus square root of 3 over negative 2, and here are my answers. So I get x equals negative 1.372 or x equals 4.372. So where on the graph are we? Well, let's go ahead and draw our y-axis. Negative 1, negative 2, 1, 2, 3, 4, 5. So this is at 1, 2, 3, 4. It's a little bit less than 4.5. And this is less than 1.5. So there's my x-intercepts. All right, how did the graph open? Go back to the problem. Okay, when you got 0 on the right, look at how the graph opened. Our a value was negative, so this graph opened down. Okay, this graph opened down, and then what did we want to know? We wanted to know when the graph was less than 0, so below the x-axis. Less than means below the x-axis. Okay, so below, not below or on. So below the x-axis would be here on below the x-axis, and then here on below the x-axis. So this is going to be when x is less than negative 1.372, or when x is greater than, my x values are getting greater to the right, 4.372. So that's my answer for this one. All right, I do have one more problem. Problem number 5. Hopefully we can make it quick. Oops, this is supposed to be in black. Okay, number 5. Negative x minus 3 squared greater than 2. Okay, so again, 0 needs to be on the right, so I need to move this 2 over, and it will become negative 2. All right, and then we're going to solve the equation. Now I know we just moved this over, but since this is in vertex form to solve, we've got to move the negative 2 back over. But we still needed to do it initially, so don't get too upset. We'll talk about why in a minute. Okay, so this becomes positive 2, and then again, you've got to divide by this negative 1, so this is x minus 3 squared equals negative 2 to get rid of that. So then I'm going to rewrite this like I've been doing for y'all. All right, and you square root, and what happens? Well, you get the absolute value of x minus 3 equals, well, that's I radical 2. We already should be stopping. Okay, the roots are imaginary. Why are the roots imaginary for this graph? Hopefully you're asking, why are the roots imaginary? Well, think about this graph. When we move 0 over to the right, all right, we got this quadratic. This quadratic that has been shifted, let's think about it. It's been shifted right 3, down 2. So right 1, 2, 3, down 1, 2. So its vertex is here, right 3, down 2, and it opens down. This graph opens down. So where are the roots? Well, they're not on the x-axis, they're imaginary, okay? But still, we have to solve the problem. Okay, the problem is asking, when is the graph, what does that symbol there stand for? Above the x-axis. When is it above the x-axis? Greater than means above. When is this graph above the x-axis? Never. It's never above the x-axis. So you would say no real solutions. Now, I want to create a problem. Problem number 6. I know I said one more. The same exact problem, but less than 2. Pretend I took the same exact problem and said less than. Of course, you would move this over, right? And you'd have negative x minus 3 squared minus 2 is less than 0. Okay, I'd be asking, when is this graph below the x-axis? And what would your answer be? Your answer for this exact same graph, when is this graph below the x-axis, would be all real numbers, because that graph would always be below the x-axis. So you have to pay attention to how the question is being asked.